Derive the distance formula for P1, point 1, ordered pair at x1, y1, and P2, the second point, located at x2, y2. Now we have the xy coordinate system here. x1, y1 is located somewhere here. Let's just pick somewhere that it could be. Doesn't matter. Let's just say it's right here. Here's P1. It's located at x1, so this value on the x-axis would be x1, and the y value would be located right there. So there's my first point, P1. And then I have a second point, P2, somewhere. Let's just say it's up here. And that's located at x2. So if you go down to the x-axis, located at x2, and then the y value is located over here. Now we want the distance between the 2 points, right here. We'll represent that with lowercase d. D for distance. Now what you can do is you can visualize a right triangle out of this. Right, that's a 90-degree angle right triangle. What we're going to do now is we're going to find this distance right here in terms of x1 and x2. So if you think of these as numbers, to find the distance between two numbers on a number line, you take the larger number and subtract from it the lower number. So in terms of the x2 and x1, this distance is going to be x2 minus x1. And you can do the same thing for the distance on this side of the triangle. We have the larger number, y2, and the smaller number represented by y1. So this distance is going to be y2 minus y1. Now the reason I did that is because for right triangles, we can use Pythagorean Theorem, which is a squared plus b squared equals c squared, where a and b are the two legs of the triangle, and c is the hypotenuse, which is d in this case. So if you use Pythagorean's theorem for a right triangle, a squared plus b squared equals c squared, since I want to solve for d, and I know d is going to be in the hypotenuse c location, let's switch it around. So I have c squared equals a squared plus b squared. All right, so c is the hypotenuse. I'm going to replace that with d. So the left-hand side is going to be d squared. The right-hand side, the a, I'm going to let that be this leg. It doesn't matter which leg you let it be, but let's do this one. So I'm going to replace a with x2 minus x1. I'm going to have to use parentheses since you're squaring the whole difference. And then I have this plus sign. And then b is going to be the other leg, y2 minus y1. And again, you're going to need parentheses. All right, so now I have the distance in terms of the coordinates of the 2 points. That would be the distance formula. Now to solve for d, you're going to have to square root both sides. Now usually when you square root both sides, you need to consider the positive and negative scenario. But since we're talking about distance, we're going to represent distance as always a positive number. So I only need to do the positive square root. So I'm going to square root both sides to get rid of that square on the d. And then on the left-hand side, the square root and square root will invert each other, their inverse properties, so they go away. So I just have d on the left-hand side, and then I'm just going to write the same exact thing right here. This is a representation of the distance between two ordered pairs. There you go.